Today we are going to learn about illustrating and translating variations. So here are the things that we are going to learn today. The first one is direct variation. Second one is inverse variation. The third one is joint variation, and last but not the least, the combined variation. But before that, what is variation? A variation is a constant change of variable parameter. And in variation, we always deal with two quantities, which is the constant and variable. Constant is a value of a quantity that remains unaltered under different situation, while variable is a value of a quantity that changes under different situation. While table of values is a table that includes a list of numbers. To substitute one variable, we use this to find a missing number. While graph is a pictorial representation used to represent a relationship between two things. So the first one is direct variation. Direct variation states that as the variable increases, the other one also increases. Same goes when the other variable decreases, the other one will also decrease. So the formula is y is equals to kx, where k is represented as the constant of variation. And the statements that we will usually encounter when dealing with direct variation are: the first one is y varies directly as x. Second one is y varies directly proportional as x. And the third one is y is proportional to x. So when illustrating the equation, always keep in mind that k is always represented as the constant of variations. So here are the sample problems. The first one is x is directly proportional to y. So the answer will be x is equal to constant of variation y. And the second one is the height or age varies directly proportional to the weight, which is w. So the answer will be h is equals to constant of variation w. So here is another sample problem. If y varies directly as x and y is equals to 25 and x is equals to 5, find the constant of variation. So first we have to illustrate the equation, which will equals to y is equals to k, or constant of variation, x. And then all we have to do is to substitute the numbers given on the problem. So it will be 25 is equals to constant of variation 5. Now, all we have to do is to add 5 to both sides. So our answer will be 5. Therefore, the constant of variation is 5. So the next one is using the table of values to solve problems. In the first problem, it is stated that the table shows that the distance, which is y, varies directly as the time, which is x, and the table has two variables, which is 2, which is the x1, and 20, which is the y. So since it is stated that y varies directly as x, we have to illustrate our equation. So it will be y is equals to kx, and using the numbers 2 and 20, the equation will be 20 is equals to k2. And we add 2 to the both sides, so therefore our constant of variation is 10. Once we have our constant of variation, all we have to do now is to just multiply it to the other variable to find the other missing numbers. So the missing numbers are 10, 30, 40, 50, and 60. The next one is the graph of direct variation. The graph of a direct variation is always a straight line. And the graph of a direct variation always intersects with the origin or the 0, 0. So the next one is inverse variation. Inverse variation states that as the other variable increases, the other one decreases. And the statements that we will usually encounter is y varies inversely as x, which can also mean or illustrated as y is equals to k over x, where k is represented as the constant of variation. So here are the sample problems. The first one is the base or b of a triangle varies inversely as its altitude or age. So the answer will be b is equals to k over age. Second one is the width of a rectangular box varies inversely as its length. If w is equals to 5 and length is equals to 12, then what is its constant of variation? Now we have to first, of course, illustrate the equation. So it will be w is equals to k over l, and then just substitute the numbers given. So it will be 5 is equals to k over 12. Now, since there's always an invisible 1 as a denominator of 5, all we have to do is just cross multiply. So the answer will be 60. Therefore, our constant of variation is 60. Here is the table problem. A motorcycle has a constant of variation 120 km. How long will it take to reach its destination if it has a rate of 120 km per hour, 40 km per hour, and 60 km per hour? So of course, since we already know the constant of variation, which is 120 km, all we have to do now is to just divide it with the given rates, which is 20, 40, and 60 km per hour. So therefore, the missing variables will be 6, 4, and 2. When it comes to the graph of inverse variation, always keep in mind that the graph of inverse is what we call hyperbola. The hyperbola will never intersect the x-axis and y-axis. And it will also never intersect with the origin, or 0, 0, unlike direct variation.
Now, let's tackle about joint variation. So based from what we read, joint variation describes a situation where one variable depends on two or more other variables. It has a similarity to direct variation, but it involves three or more variables. Now, this is the statement we will usually see when dealing with joint variation. Y varies jointly as x, w, and z, which can also be translated as y equals k x w z. W varies jointly as x, y, and z. So our answer will be w is equal to constant of variation w, y, and z. So first we have to translate the problem, so it will be x is equal to constant of variation multiplied by w, y, and z. Now, we have to illustrate the equation by substituting the given values for the values, so it will be 18 is equal to constant of variation multiplied by 2, 6, and 5. Then calculate it. After calculating, our constant of variation will be 3 over 10. Now, in order to find the x, just substitute the given values and out constant of variation, so our answer will be x is equals to 54.
Now, let's learn about combined variation. Combined variation involves both inverse and direct variation. Combined variation describes a situation where a variable depends on two or more other variables and varies directly with some of them and varies inversely with others. Now, this is the statement we will usually see when dealing with combined variation. Y varies directly as x and inversely as w, which can also be translated as. Now, let's see the sample problems. X varies directly as p and w and inversely as b. So our answer will be x is equal to constant of variation multiplied by p and w over b. If y varies directly as x and inversely as z, where y equals 24, x equals 48, and z equals 4, find x when y equals 44 and z equals 6. So first, let's translate our given. So it will be y is equal to constant of variation multiplied by x over z, and illustrate the equation by substituting the values given. So it will be 24 is equal to constant of variation multiplied by 48 over 4, then calculate. Therefore, our constant variation will be 2. Now, to find the x, just substitute the constant operation and the other given values, so it will be and calculate. So our x will be 133.